This video is over lesson 59, adding integers on the number line, and it is for my 7th grade math class. So throughout this lesson, I have made a lot of number lines that you'll see here in a little bit. Be aware that you're going to have to make these yourselves on your homework, and as you make them, we generally, though we don't always have to, we do generally put 0 in the middle. And then off to the right, we find a certain group of numbers. Off to the left, we find a certain group of numbers. We're going to talk about that in just a second. But notice my tick marks. I've done it nicely on the computer. All my tick marks are nice and spaced out. So the distance from this tick mark to that tick mark is the same distance as this tick mark to that tick mark. Same distance, same distance, same distance, and likewise going the other way. You should be doing that to the best of your ability on your homework as well. The other thing to point out here is that these lines have arrows at the end to show that the lines go on forever. Now I will say this, when we make these on our homework, typically we don't put this last tick mark on here. I just didn't have a good way of getting rid of that on the computer. So I had to go with it. But for you, you can just go ahead and leave off those last tick marks and just have your arrows at the end. So yours will look something like that. So let's go ahead and dive in here. So adding integers on the number line. So integers are all natural numbers. Now natural numbers is just the proper name for what we more commonly refer to as the counting numbers. So just like you learned to do way back before you entered school, 1, 2, 3, 4, 5, 6, 7. So these are my counting numbers here, 1, 2, 3, 4, 5, and on and on and on. And one of the things that we notice about all of the counting numbers is that these are all the positive integers. They're all the positive integers. And so with each of them, there is an invisible positive sign. These are the numbers we're so used to using that we don't bother putting that positive sign on, but it's there. It's just usually invisible. So if you want to make it visible, it looks just like a little plus sign. Usually it's made smaller and raised up a little bit, but it looks like that. So +1, +2, +3, +4, and +5 here. And again, normally we don't put those positive symbols on there because these are the numbers we use most commonly. So if there is no symbol, we assume it's positive. The integers are also the opposites of the natural numbers. So -1, -2, -3, -4, -5. So if you count, but just put negative in front of it, that is the opposites of the natural numbers. So obviously these are the negative integers. And then finally, if we look at our number line, hopefully we can see that where we normally put our tick marks, those are all the integers so far. Well, we've obviously left one out, 0. Zero is neither positive nor negative. So 0 does not have a positive sign, 0 does not have a negative sign. It's neither. So related to that is this idea called signed numbers. Signed numbers. So signed numbers are any number except 0. So these numbers either have a positive sign or a negative sign. So 0 is not a signed number. Well, the absolute value of a number is a way of looking at its value. Okay, or in this case, it's going to be is the distance. We're going to think of the value as the distance of that number from 0. So if I come up to my number line here, if I consider the distance from 0, hopefully you can see that -1 and +1 will have the same absolute value since they're both a distance of 1 unit from 0. -2 and +2 will have the same absolute value since they both have a distance of 2 units from 0, and so on and so on and so on. So down here, let's take a look in our chart real quick. So our first number here, we have the number 4. Now remember that this really is a positive 4. So if we were to write this out in words, sometimes, just to emphasize it, we might write positive, but not usually. So I'm going to do that in red. It's something we should be thinking, but we don't always have to write or say. And then obviously 4, F-O-U-R. So what is the sign on 4? Well, it's positive. And so what is its absolute value? Well, how many units away is 4 from 0? Well, it's 4 units away. Our next number is -5. So in words, the negative is required. So I'm going to write that in pencil. The sign obviously is negative. And the absolute value, well, how far away is -5 from 0? Well, -5 is 1, 2, 3, 4, 5 units away. Right here we find negative, that's required, 19. Obviously its sign is negative, and so its absolute value, how far away is -19 from 0? Hopefully you're kind of catching on to this right now. Well, how many units would that be from 0? 19 units. And then 36 here implies that we're talking about a positive 36. And so the positive we don't usually mention, but we can if we need to emphasize it for some reason. And then remember, ladies and gentlemen, that when you're writing 2-digit numbers like 36, they're hyphenated. So 30-6. And then, sure enough, it is positive. So how far away is a positive 36 from 0? Well, 36 units from 0. So, ladies and gentlemen, one of the things that absolute value does is it takes these, which if we think about a number line, a positive 4 would be 4 units to the right. A -5 would be 5 units to the left. A -19, 19 units to the left. A positive 36 would be 36 units to the right of 0. But what absolute value does is it basically strips off these signs. And so we no longer know, are we going right or left? It just tells us how far to go. So if I know I have an absolute value of 4, I don't know if that's 4 though to the right, so positive 4, or 4 units to the left, -4. It's when I put the absolute value together with the sign that we know the true value of the number. And then our last one here, we have 0, which is neither positive nor negative, so sign none. How far away is 0 from 0? 0. So absolute value of x is written as this guy right here. So what we do is we take these vertical lines, two vertical lines, and put them on either side of the x. And typically you want these long enough that they're not going to look like ones. So you want to exaggerate them just a little bit so that it's not looking like ones. The absolute value symbols are similar to parentheses. So in the order of operations, absolute values are part of the parentheses step. So grab your highlighter here, absolute value, and highlight just that P there. So remember, PEMDAS is the nonsense word we use to help us remember our order of operations. So when it comes to the order of operations, this is where it's going to fall. So when we're doing an order of operations problem, we're going to do everything inside the absolute values first, then we'll find the absolute value. So everything inside comes first, then the absolute value. So we're going to do some problems down here together. Here we go. Absolute value of a positive 4. Now normally we don't have to write that positive 4. I chose to put it in just to emphasize it today. So absolute value of positive 4, how far away is 4 from 0? Well, it's 4 units away. Absolute value of negative 4, how far away is negative 4 from 0? It's 4 units away. Absolute value of positive 5, how far away is positive 5 from 0? 5 units away. Now if you're feeling pretty good about these, go ahead and pause the video and do just up to here. We'll do these guys together here. But just up to here. And then this little guy down here that's hiding on my video, you can do him too. Okay, so you can do these, and then we'll come back together to do those together. So pause if you want to go ahead and do those. All right, here we go. So distance of negative 5 from 0 is 5. This distance of 19, positive 19 from 0 is 19. The distance of negative 19 is 19. The distance of positive 36 from 0 is 36. The distance of negative 36 from 0 is still 36. And then how far away is 0 from 0? Well, we already said the absolute value of 0 is 0. 0 is 0 units from itself. So now if we move over here, we're thinking more order of operations. So these last 9 examples were really just doing the problems, just absolute values. So now we've got more going on. We've got other operations that we need to take into consideration. And you notice these problems are somewhat similar to each other. And we're going to see what differences they make. So first up here, 8 minus 6, the absolute value of 8 minus 6. So since we find the 8 minus 6 inside of the absolute values, we've got to do that first. So I'm still going to have an absolute value, but I'm going to simplify 8 minus 6. So 8 minus 6 is 2. Now, how far away is 2 from 0? 2 units away. For our next one, absolute value of 6 minus 8. So the 6 minus 8 is inside, so I'm going to do that first. So still going to have an absolute value, but 6 minus 8, so if you have $6 and I take away 8 of them, well, you're not going to have enough for me to take all that from you. So I'll get the whole $6, but you'll still owe me, that's a negative, $2. Well, how far away is a negative 2 from a 0? It's 2 away. For our next one, notice that the plus sign is not inside this pair of absolute values or this pair of absolute values. So this plus sign here is going to happen after I do both of my absolute values. So nothing to do inside. Let's just go ahead and do the absolute value then. Absolute value of 6 is 6. Plus the absolute value of negative 8 is 8. And then 6 plus 8 is 14. Next one, same deal. This is a pair of absolute values, nothing to do inside of them. This is a pair of absolute values, nothing to do inside of them. So I'll do each absolute value, then the subtraction. So since the addition here and the subtraction here were not inside, then they're part of this step down here. So absolute value of 6 is 6, minus the absolute value of negative 8 is 8, and 6 minus 8 is negative 2. So once again, just to make sure we understand what's going on here, when you find the minus, or the plus, or the times, or the divide inside of the absolute value, you've got to do it as if it had parentheses around it. Then you'll do the absolute value last. Down here, if you find an example like this, where your plus, your minus, your multiply, your divide, your exponent is not inside of your absolute value, then those operations will be after you do your absolute value. So it'll be absolute value, then the outside stuff. Okay. Well, we're going to go ahead and move on now. And we're going to start to put this together. And this is going to help us to add positives and negatives. That's our ultimate goal here, is to add positives and negatives. So our first example would be a negative 4 plus a positive 4. And the purpose of going through absolute value and signs is to get you thinking about what makes up a number. So each number is made up of two things, except for 0. And that's an absolute value and a sign. So the absolute value tells me a distance to go, but the sign tells me what direction to go in. And of course, 0 just tells me stay put. So we always start at 0. So on your homework, you're going to make these number lines. And they don't always have to be this big. As you get more comfortable with these, you can kind of think through, all right, how big do I need my number line to be for this problem? That'll start to become more natural. But make sure that you do evenly space out your tick marks, make them nice and neat. Okay. So what we do to model addition and subtraction of integers, positives and negatives, is we're going to make a number line. Now on your homework, you don't have to make this red line, but I'm doing that as kind of our starting place. We are always going to start in the middle with 0. And what I'm going to do is I'm going to make a tick mark above 0. Make a tick mark above 0. Hopefully you can see that. It seems like it's shining a little bit with my light. Okay, so I got my tick mark there above 0. And I'm going to now do what this number says. So the absolute value of this number is 4. We're going to go a distance of 4. So either 4 to the right or 4 to the left. The sign here, a negative, tells me to go 4 to the left. So I'm going to go 1, 2, 3, 4 units to the left. I'm going to put an arrow there to say that's how far I went, and I'm going to finish it off with another tick mark. We're going to have lots of tick marks today. And then I'm going to label this. This is my negative 4. Now, above that, so that's my first number, we are going to start where we left off. So if this is you traveling, you started here at 0, you've now gone 4 units to the left. This is where you are now. This is your next instruction. Your next instruction is to go a distance of 4 again, but a positive tells you to go 4 to the right. Positives are to the right. So if I go 1, 2, 3, 4 units to the right, I'm going to draw my arrow, put my new tick mark in. This is my positive 4. And then it's not going to be very easy to see on this one. I'm going to draw a dashed line down to the number line, and wherever that dashed line hits the number line, that is my answer. So my answer to this problem is 0. So -4 plus a +4 is 0. So if you think about this, this problem is almost like telling you to take 4 steps to the left and then take 4 steps to the right, and where do you end up? Well, 0. You end up right where you started. It's as if you didn't move. It's as if you took 0 steps. Let's take a look at the next example. We have a -3 plus a +5. So -3 is my first number. Remember, we're going to start with a tick mark above 0. We always start above 0. So we're going to go 3 units, so either 3 to the right or 3 to the left. But a negative tells me to go to the left. So 1, 2, 3 units to the left. There's my -3. We start where we left off. So I'm going to put a tick mark above where that ended. And now my next number is a +5. A +5 tells me to go 5 units, but the positive tells me to take them to the right. So if I go 1, 2, 3 units, that takes me back to 0. But remember, we got to go a total of 5. So 4, 5. There's my +5. We'll label each arrow. So my -3 takes me 3 to the left. +5 then takes me 5 to the right. And I'm going to do a dashed line. You should be able to see my dashed line better this time because it's not going through that red line. So where do we end? Down here at +2. So if you go 3 steps to the left and you go 5 steps to the right, it's the same as if you had just gone 2 steps to the right. Next example, a -4 plus a -2. So my first number tells me to go 4 units, but take them to the left. Negative is left. So I'll start at 0, and 1, 2, 3, 4 units to the left. Put my tick mark there. So that's my -4. And then I'll make a tick mark above. And then a -2 tells me to go 2 units now, but it tells me to continue going left. So if I continue going left, 1, 2, I'm going to end up right there. So 4 units to the left and then 2 more units to the left. Dashed line down. I end at -6. And really I should circle my answers here. All right, let's keep going. So next example, we have a +1 plus a -8. So this time, we're starting with a positive. So +1 tells me to start by going 1 unit, but go to the right. So that's going to be a short arrow. So there's my +1, just 1 unit to the right. And so we'll start where we left off. The next number, -8, tells me to go 8 units, but take them to the left. So 1, 2, 3, 4, 5, 6, 7, 8 units to the left. That's my -8. Dash line down. Our answer is -7. Now for our next example, you'll notice our number line's a little bit different. I didn't count by ones this time. So with a number like 5 and 25, noticing these are both multiples of 5, I made my scale of my number line multiples of 5 as well. And so the benefit here of doing that is that I don't have to actually make 25 tick marks for 25. So, but we'll still start in the middle. A -5 will tell me to go 5 units, but to the left. 5 units to the left, though, this time is just going to mean that first tick mark, because that's my 5 units right there. So if I come up here, now I'm going to go 25 units, but to the right. Positive will be to the right. So remembering that each space here is 5, so this is 5, 10, 15, 20, 25. Oops, sorry, I forgot to label my -5 down there. This is my positive 25. Dash line down, answer is a positive 20. And let's go ahead and flip over. We'll keep going. So at this point, if you're feeling pretty good about these, I would say give yourself a challenge. Maybe do some pausing here and try some problems out. Maybe you just pause once between every problem. Maybe you pause and you do the whole thing and then hit play and see how you did. Maybe you pause and try 2 problems and then hit play and see how you did. But I'd say go ahead and give it a shot if you feel up for it. So here we go. Next one. So I got positive 7 and a positive 2. Now this should be pretty easy. We already know positive 7 plus positive 2. That's just 7 plus 2. This is 9. But we want to learn how to model this. Okay, that's the point of the lesson today. We want to learn how to model this on a number line. So I'm going to start at 0. A positive 7. Positive tells me to go 1, 2, 3, 4, 5, 6. Oop, I went too far. 7 to the right. Start where you stopped. Positive 2 tells me to go 2 more to the right. So there's my positive 7, there's my positive 2. Dash line down confirms. Sure enough, the answer is 9, just like we've known since elementary school. It's kindergarten. Next up, -3 plus -6. So this time I've got a -3. So -3, 3 units, but I'm going to go negative, so left. 1, 2, 3 to the left. There's my -3. Start where we stopped. And a -6 will tell me to go 6 units, but keep going to the left. So negative tells me go to the left. So 1, 2, 3, 4, 5, 6 units to the left. There's my -6. Turns out a -3 plus a -6 is a -9. Next problem. Positive 2 plus -3. So positive 2 tells me to go 2, but go to the right. Positive tells us to go to the right. So there's my positive 2. Up here, my -3 tells me to go 1, 2, 3 to the left. Dash line down. A positive 2 plus a -3 is a -1. All right, next one. -1 plus -1. So start at 0. My first -1 is going to tell me to go 1 unit to the left. My second -1 is going to tell me to continue going 1 unit to the left. And so the answer is, and if you're catching on to this, hopefully you realize pretty quickly that that would be a -2. And then finally, our last example here. -2 plus +5 plus -4. So we can do this with more than just 2 integers. We can do it with 3 or 4 or 5 or any number of integers. So we'll do this guy here. And we just take them one at a time. Always start at 0. So 0, my -2 tells me to go 2 units, but take it to the left. So left 1, 2 units. That's my -2. Then the next number starts where the last number stopped. So my next number is a +5, so I'm going to go 5 units, but positive tells me to go to the right. So 1, 2 will take me back to 0, 3, 4, 5. That's my +5. And finally, my third number will end where the second one ended, or third number will start where the second one ended. And so my last number, a -4, tells me to go 4 units, but negative tells me to take it to the left. So 1, 2, 3, and 4. And then I'm going to do a dashed line down to the bottom. And so our answer is a -1. Now, ladies and gentlemen, as you continue to do these more and more, and as you begin to think about what's happening here, you may begin to discover some shortcuts for how to add and subtract positives and negatives without needing a number line. And that's good. You should actually begin to start to notice some of those things. We will actually discuss those more in a future lesson. Last thing on your packet here, I have included a bunch of blank problems here and number lines. We are not actually going to fill these in together. These are just extra for your use if you would find them helpful on the homework. They are there for you to kind of fill in and remember how to structure your problems. So those are there for you just as extra. We're not going to fill them in, which means that this, or I should say that this, is the end of the lesson.